So today I will be talking about the conjecture explanation, my conjecture of course. To begin with, I have a simple table which is divided into three columns: the exponential form, the standard form, and the extended form column. The exponential form column holds 2 raised to the power of 4, 2 raised to the power of 3, and so on and so forth until it becomes 2 raised to the power of negative 4. The column next to this column is the standard form column, which basically shows the whole number version. So 2 raised to the power of 4 will obviously become 16 because it's 2 multiplied by 2 multiplied by 2 multiplied by 2, which is shown in the extended form next to the standard column, and the rest of the numbers follows. My conjecture is that x raised to the power of n multiplied by x raised to the power of negative n equals 1, provided that x is not 0, and this equation can also be reversed into x raised to the power of n multiplied by x raised to the power of negative n equals 0, once again provided that x is not 0. The description for this conjecture is that any base x raised to the power of n multiplied by the same base x raised to the power of negative n will have a product of x raised to the power of n minus n, which is x raised to the power of 0. And x to the power of 0 is always 1, provided that x is not 0. This is my evidence and explanation, so just a few examples to prove my conjecture. 2 raised to the power of 2 multiplied by 2 raised to the power of negative 2 equals 2 multiplied by 2 multiplied by half multiplied by half, which equals 4 multiplied by 1/4, which is 1. Next, 3 raised to the power of 5 multiplied by 3 raised to the power of negative 5 equals 9 multiplied by 9 multiplied by 3 multiplied by 1 over 9 multiplied by 1 over 9 multiplied by 1/3, which equals 9 multiplied by 9 multiplied by 1 over 9 multiplied by 1 over 9, which equals 1 multiplied by 1, which is obviously 1. The final evidence is 2 raised to the power of 3 multiplied by 2 raised to the power of negative 3, which equals 8 multiplied by 1 over 8, which equals 1. So as you can see, all of the numbers have the same bases when they were multiplied, and their exponents were of opposite value, and they all resulted in 1. My verification and justification is, first of all, by using another law, which tells us that x raised to the power of negative n equals 1 over x raised to the power of n. We can apply this law to our conjecture. So basically, x raised to the power of minus n in our conjecture becomes 1 over x raised to the power of n, which becomes x raised to the power of n multiplied by 1 over x raised to the power of n, which then makes the x raised to the power of n go in the numerator and the denominator, which then causes them to simplify each other and become 1. Another law we can use is the product law of exponents. If you multiply two numbers with the same bases, we can add the exponents. In this case, the two exponents we will be adding would be n and negative n, which is basically n minus n, which is 0. Thus, the base to the power of 0 will always result in 1 unless the base is 0.